Welcome to my channel. I'm Zhan Xu. Let's look at the problem 13 in chapter 23. Chapter 23 is about electric potential. So we look at this system. It tells us the Earth produces the inward keyword electric field and the magnitude is given. So we can draw it inward is pointing to the center, right? E naught. Next one, what is the potential difference of the surface relatively to V equal to 0 at the R equal to infinity? So this one we consider the function, this function in our textbook, right? So in this textbook, we can see we know the Earth is a spherical object. If it carries the charge Q, the electric field can be written as this one, right? Yes, Q divided by 4 pi epsilon naught R squared. And then it pointing inward. This is given us at the surface. The E naught is Q divided by 4 pi epsilon naught R naught squared. Now we just use this function inside. Now you can see we know at the infinity, really far away at infinity, the V equal to 0. So that means we can replace A as infinity. And then in this case, VA will become 0. Do you agree? Yes. And B, this is what we are interested in. We are interested in the Earth's surface. So the B is R naught. V R naught. So this is what we are interested, right? So we write it as Vx. And then in this case, you can see we replace A as infinity, B as R naught. We write it there. Now you can see this is E dot dl. This is a vector dot operation, right? It tells us E is inward, as we know dl must be outward. So you can see this two vector dot will produce a negative sign. So this negative sign can be cancelled, right? So in this case, you can get the function look like this one. Input the E and then times dr. And do this integral, you get a function. You get this term. And then this term is 0. So Vx equal to negative E naught R naught. And then get the answer there, right? Because there, you can see the Vx just equal to negative Q divided by 4 pi epsilon naught R naught squared. And we can replace this term as E naught times R naught. The next case tells us if the potential of the Earth is 0. So that means at the surface of the Earth, V equal to 0, right? V equal to 0 at this surface. Now you need to find the potential at infinity. So how can we do that? We can consider still this function, right? This is a function in our textbook. And then this one, what is given is the R naught, right? We know at the R naught, this is the Earth's surface, the VA equal to 0. Agree? In this case, B becomes a negative. Or B becomes infinity, sorry. B becomes infinity. A becomes the R naught. So we input it inside. VA becomes a 0. And A becomes R naught. B becomes infinity. And in this case, E dot dl. Agree? As we talk about, E is inward, dl is outward. So this two vector dot operation will bring one negative sign and cancels with this negative sign. So we get the answer look like this one. Do this integral, you get the answer at there. And finally, you can see this 0 can cancel. So Vx just equal to E naught times R naught. You can replace this term with the E naught times R naught. Thank you.